Now we want to use Archimedes principle to find out why pinewood does not sink in water. Well, look at the density of pinewood. It's 550 kilograms per meters cube. And the density of water is 1,000 kilograms per meters cube. Looking at the densities, we can tell why pinewood will not actually sink in water. That's easy. But we're going to use Archimedes principle, and to do that, we need to use forces, because that's what Archimedes principle is based on. Okay, so to use forces, let's find the buoyant force of water acting on the pineapple ball, as if the pinewood ball was submerged in water. Okay, I need to give you here that the radius of the pinewood ball is a huge sphere, is actually equal to 3 meters. It's a big sphere. Okay, so the buoyant force is equal to the weight of the displaced fluid. The displaced fluid is water, and then you have to say raw water times the volume of the displaced fluid as if it was submerged, which is water, and that then the G. Okay, now this equation becomes the density of water. The volume of a sphere is 4 over 3 pi r cubed, and G comes back as it is. And if we plug in the number, the density of water is 1,000 times 4 over 3 times pi times the radius, which is 3 cubed is 3 times 3 times 3, and that's 27, times 9.8. And if you do this calculation, you are going to get 1,100,792 Newton. That's a huge force. Okay, now let's find what the ball weight is from, so let's find the weight of the pinewood ball, and that would be equal to the density of the pinewood, okay, times the volume of the pinewood times G. Okay, the density of the pinewood is 550. The volume of the pinewood is again 4 over 3 pi r cubed, where r is the same, still 3 meters, and G is 9.8. And with quick calculations, we get the weight of the ball is 609,285 Newton. Okay, now look at this number we got here, and look at this number we got here. You can see that the buoyant force is 1 million and some change, while the weight of the ball is 600,000 and some change. So as you can see, FB is much bigger than the weight of the ball, and that's why FB wins, and eventually the ball will float. Okay, now what if we did something different? Take this ball and make part of it into a raft. This raft is a square raft that has 4 meters on a side and 4 meters on a side here, and the thickness of it is 0.4 meters. Of course, when you put this raft in the water, some of it will be submerged underwater, as you can see. We need to find how much of it is submerged underwater. Basically, we need to find what is H submerged underwater. Well, how do we go about doing that? If we notice that the weight of the raft and the buoyant force are at equilibrium, because the raft is not sinking and the buoyant force is not pushing the raft out of the water, there's no acceleration here. So we know the principle that the weight of the raft must be equal to the force of the buoyant force, or the buoyant force. Okay, all right. Now, how much of the raft is underwater? The volume of the raft that is underwater, which will displace what? The same amount of water out, is equal to 4 times 4 times h. So this is how we find h. So we that's one of the other keys. Okay. Now, what is the weight of the raft? The weight of the raft is basically equal to the density of the raft times the volume of the raft, the total volume of the raft, times g, and the density of the raft is 550. The volume is 4 times its thickness, which is 0.4. Okay, and times g, which is 9.8. And if we calculate all of this number, we will get 34,496 newtons. So that's the weight of the raft. Now let's find the buoyant forces. The buoyant force acted on the raft by the water. So that will be the water that is acting, doing the force. So the water is being displaced. So that density of water times the volume of water times g. Okay, and the density of water is 1,000. The volume of the displaced water is basically 4 times how much of the raft was sunk, which is h, under the, or submerged underwater. Okay, times 9.8. Now these are equal. These quantities, these two quantities are equal. If you put them equal to each other, you can find out that the only unknown is h. So let's put them equal to each other. 34,496 is equal to 4 times 4 is 16, so that's 16,000 times 9.8 times h. The only unknown is h. With some calculations, you can find h is equal to 0.22 meters. So that's what h is 0.22 meters, and that's how much of this will be submerged underwater. Okay, thank you very much.